County, and she's talking on microbial hygiene considerations with mechanical harvesting of blueberries. Thanks, Renee.
Sorry, I'm short, so I'm lowering the microphone right now, and then it wanted to fall off on me. Thanks for having me here today. Y'all have an absolutely gorgeous state, and I love coming to visit every time. Today I want to talk to you about a project with dealing more with food safety on mechanical harvesters and blueberries. And I'm an area extension agent. I just focus on commercial blueberry production. I'm also a PhD student, and part of this is part of my dissertation. This is a collaborative project with a guy named Dr. Harold Sherm. He's now our new department head at the University of Georgia in the Department of Plant Pathology in Athens. And then also we're working with microbiologist Dr. Jennifer Chin. She's out of Griffin, Georgia, and she's in the food science department. A little bit of background about the Georgia blueberry industry. We're located throughout the state, but primarily most of the commercial production is in the southeastern corner of Georgia. And we operate in fresh and frozen markets, almost half and half here. About 52 million pounds of fresh and 40 million pounds of processed fruit. We have a couple different species we work with on the commercial scale, rabbit eye and also southern highbush blueberries. And our estimated production value is over 335 million, and that's from 2014 Georgia Farm Gate Value Report. A little bit of background about, where we're coming from on this project. I want to talk a little bit about food safety and the implications of it. So the marketers and the clients, they require a product from the farms and the packing plants to be inspected by third-party audits. And an example of one of those audits, the Primus GFS audit. It's a very intense audit, and these audits, they require intense cleaning and sanitization protocols. And, so far, microbial hygiene has been mainly focused on the packing plants, but not much focus on the farm level. And the current practice could be that the growers may or may not rinse the harvesters, for example. I hear Washington's doing pretty good with some of their cleaning and sanitization protocols, and I applaud you for that. And Georgia's becoming better too. But with the Food Safety and Modernization Act that came down, that also requires better cleaning and sanitization in the fresh product industry. So again, we just wanted to focus more at the farm level and see what we can do to help the growers out with some of these new things coming down. And another consideration is when they export the fruit, that's also tested for microbes upon delivery. So you want to make sure your fruit passes on that level as well. A little bit of background about human disease outbreaks in the blueberry industry. Fortunately, not very many at all. 3, as you can see here, which is awesome. From New Zealand, they did have an issue with hepatitis A on some blueberries. There were 43 cases and actually 1 death. That was because of contamination from infected food handlers or contaminated groundwater from pit latrines located near the orchard and not having hand washing facilities. Of course, this is something that we have addressed in the U.S. We don't have pit latrines near the orchards, and we have hand washing facilities at our orchards. So that's very good that we have those things in place to prevent foodborne outbreak. Another case of salmonella, happened in the United States. 14 cases of sickness, and that was a product that was consumed in private homes. Not a lot of information reported about that one. And then we did have 1 instance in fresh blueberries. They came from Georgia, and it was traced back to a single grower, but there was a salmonella issue, and the outbreak happened in Minnesota, and a few cases of sickness there. So we're very happy that we only have a limited number of cases. We want to keep it that way. We don't want to add to that list, and we did not have any listeria outbreaks, so that's good to know as well. But we do want to take due diligence, and we definitely, across all states that work in the blueberry industry, we do not want a foodborne illness outbreak, because no matter where that outbreak occurs, that could affect the industry as a whole, through negative press and whatnot. So cleaning and sanitization of farm equipment. It's been recommended for decades. There are a few different papers out there on it, of course. But recently, we're really starting to see the practical application of this. So really, the growers are starting to be more cognizant of the movement of plant pathogens from field to field through equipment, but also from a food safety perspective. You know, when we want to keep down on dirt and debris, because when that's present, you know, microbes are present. And but the problem is that the farmers find that the sanitization protocols are time consuming and labor intensive. So the purpose of this research is to kind of get this process going, see what we're working with, and see what we can put in place to make it as painless as possible on the growers. So first, I just want to get a general feel for the microbial load and the level of different indicator organisms on the mechanical harvester surfaces. I can't decide on, you know, cleaning and sanitization recommendations and such if you don't know where you're at to begin with. So we just wanted to kind of look at that first. So back in 2015 and 2016, and this is part of the food safety portion of a SCRI grant on harvest mechanization and efficiency. But we determined the microbial loads on different harvester surfaces during different times of the day. So we did an AM, noon, and evening time point. And we just want to find out, okay, what are the most problematic surfaces for cleaning and sanitization on the harvester? And we want to determine those microbial loads on the fruit, too. I mean, that's what we're most concerned about, right, is the fruit. And we wanted to look and see what the loads were on the fruit before they passed through the harvester and after they passed through the harvester to see, you know, does that harvester increase the microbial risk? And as I mentioned, I focused on environmental indicator organisms. So I didn't specifically test for particular organisms, but just get a feel, you know, what's the general microbial load? You know, how many total aerobic bacteria do we have? How many total yeasts and molds do we have? And, you know, because higher microbial load could impact, you know, post-harvest decay and fruit quality. So there's other issues that these things can cause in addition, you know, to food safety. And another thing to keep in mind, particularly with yeast and molds, is that, you know, high numbers of those can increase the risk of mycotoxin production. So we don't want that to occur in the product. You tend to hear more about that in kind of grain type products where they have those types of issues. So, but in general, just in food products, we just want to keep those counts low. And then, of course, I wanted to look at indicators of fecal contamination because that's a big concern, right? So I looked at Enterococci, gram-positive organism, and coliforms and fecal coliforms. You know, the fecal coliforms are of greatest concern because they're an indicator of the presence of E. coli and other pathogens potentially. And so these were plated on different microbiological media that help culture these types of organisms. The particular surfaces I looked at and what they're made out of, I looked at the beater bars or the rods. They're made out of acetyl-delrin plastic. Conveyor belts, some of the plastic mesh conveyor belts. The lugs, which are made of a high-density polyethylene. Catcher pans, or we call them fish scales in Georgia. They're made out of plexiglass. Some of the newer ones are made out of extruded polycarbonate. But the ones I tested here were just kind of the harvesters we had in Georgia at the time. Stainless steel, of course, so there's a couple different grades of stainless steel. We have metal conveyor belts, and then inside the harvester, the sides of them, you know, have that commercial grade stainless steel. And then for top-loading harvesters, they have a filling flap at the top at the end of the vertical elevator there, and that was made out of a rubberized plastic canvas. And I do want to note some of the new harvesters have made improvements on some of those types of materials that are a little bit more food safety conscious as far as the filling flap and that sort of thing goes. So just visually showing you what these different areas look like on the harvester. You know, I sampled an upper rod, kind of an upper third, and a lower rod in the lower third of the harvester. The upper wall and the lower wall, and this was back behind the beater bars, so if there's going to be some plant debris or whatnot, that would kind of splatter up against the backside of the wall there. The fish scales or the catcher pans. The conveyor belt. The lugs. And, you know, I was having questions from growers about, you know, bottom loader versus top loading harvesters. So I did sample top loaders as well. And I had 2 additional samples for those types of harvesters, the vertical elevator there, which is another conveyor belt, and then the filling flap. So how I did this is I swabbed 7 harvesters in 2 different years at 3 different time points. I swabbed 100 square centimeter surface area with a sterile sponge that had a little bit of buffer on it. Collected that sponge, put it in a sterile sampling bag, and dilution plated that buffer, that nutrient medium, in duplicate on appropriate media, as previously described. And for the fruit, again, this is what we're really concerned about. I took about 50 grams of what I called pre-fruit, was basically from the bush on the row before the harvester went down that row. And then I took 50 grams of fruit post, after it had traveled through the harvester. Put it through a rinse for about 30 minutes in PBS buffer and dilution plated that solution. So I'm just going to present the 2016 results because they were about the same between the 2 years. First, I want to talk about the total aerobic bacteria. So as you can see here on the vertical axis, we have the different harvester surfaces, the rods at the top, upper wall, lower wall, catcher plate, and the conveyor belt and lug at the end here. And on the horizontal axis, I have the number of what we call CFUs, colony forming units, per square centimeter of surface area. And as you can see, the upper and lower rods do not have necessarily a lot of bacteria per se. You're getting, 4 to 5 logs, but you see larger amounts of bacteria on the lower wall, the catcher plate, and the conveyor belt. In particular, that conveyor belt, we can get up to, say, 8 logs there of bacteria, but not so much on the lug and some of these other surfaces. So it did vary per surface area. And the different color bars are for the different time points. And I do not show the significant differences there, but I'll address that in a moment here. But similar trends between the different times and the different surfaces as far as the level of microbes you're getting. A little bit of variation there. Then if we look at the total yeast and mold, again, a similar trend. You have significantly higher amount of those microbes on the catcher plate and the conveyor belt as compared to the rods and the internal walls and the lug. But less amount. So, on the high end, you're a little bit above 4 logs, and the low end, you're getting more just like 2 logs of yeast and mold. For the coliforms, we do have some, but as you can see, the scale has changed here. And instead of reporting in logs, we have much less. You're talking about 100 organisms on the higher, on the surfaces that tend to have higher amount of microbes. So on the catcher plate and the conveyor belt, you have like maybe 100 organisms, but you're getting lower on for example, your rods. You may only have, say, 10 organisms in that square centimeter. Fecal coliforms, they're detected sporadically, and again, similar trend. You do have some of those on the catcher plate and conveyor belt, but if you look at our scale here, now you're getting only about 10 or a little bit over that. So you're talking about a lot less organisms with the fecal coliforms, and then not very many at all, on the rods and the walls. It's kind of interesting. We did find kind of higher amount of fecal coliforms on the lugs, and I'll kind of address what the growers can look out for on that in a moment here. And then the Enterococci organisms, again, it's an indicator of contamination, but we did not find Enterococci on the upper rods, lower rods, the walls. We did find some on the catcher plates and the conveyor belt. Again, you're seeing a theme here, right? We tend to have higher amounts of microorganisms in that area. But as far as time of day, when I sampled, and again, you might be wondering, well, why did you test different times of day? We didn't know if maybe it would stand out that we have much higher organisms, say, at the noon time point. So maybe during the lunch break, that might be the best time for the growers to clean and rinse the harvester. But in general, the time was not significant. In some cases, with some of the organismal groups, it was significant, but overall, not significant. And so let's take a look at the fruit samples, again, because that's what we're really concerned about, because that's the product going out to the clients and consumers. If you compare the pre-fruit, and again, we have the different colorations are for the different time points, white for AM, gray for noon, and black for PM. We had no significant difference between the pre-fruit and the post-fruit on the number of colony-forming units per gram of blueberry material. So that's the total aerobic. I'll go to the total yeast and mold. Again, no significant difference between the pre-fruit and the post-fruit. And again, we're getting, somewhat lower levels. You're getting only up to, say, 3 logs here. The coliforms, again, the scale has changed. So the bars seem higher, but the scale has changed. So instead of talking in terms of logs of organisms, a lot of organisms, we're only talking about 100 or maybe even 10. And no significant difference between the pre-fruit and the post-fruit. So this is the really good news here, right? So here in this table, I have p-values from the mixed model analysis of variance for the effects of the fruit location, before entering the harvester versus after leaving the harvester, and then the different time points, AM, noon, PM, on the population density of these indicator organisms across 7 different blueberry mechanical harvesters in 2015 and 2016. And if you look, all these p-values, which the scientists would probably understand this more than the growers, but basically it's not significant. You're looking for less than 0.05 is kind of what we shoot for, and none of it is significant. So in conclusion, yes, the harvester surfaces were significant for all groups of the indicator organisms. So depending on where the microorganism is in the harvester, which harvester surface, you may have more or less of them with total aerobic bacteria, yeast and mold, coliforms, fecal coliforms, and Enterococci. 2015, the surfaces were significant for 3 out of the 5 organism groups, so a similar trend. The populations were consistently highest on the horizontal conveyor belt, the catcher plate, followed by either the lower wall or the lug. So again, those are areas we want to target with cleaning and sanitization. And the time was only significant 2 out of 5 cases each year, so in general not significant. But when it was significant in both years, it was significant for fecal coliforms at AM. So in South Georgia, we have the dew falls. There's more moisture, so that may be contributing to that. But the very important take-home message here, and I want this to go up the ladder really with the companies and food safety people, is that in none of the cases was the microbial load increased significantly for the fruit after they left the harvester compared with before they entered it. So this is really good news. That harvester is not adding additional microbial insult to the fruit. So tentatively, we conclude that the harvester surfaces carry high microbial loads. The conveyors, the catcher plates, the lower walls, and even the lugs tend to have the highest microbial loads, particularly for total aerobic bacteria, yeast and mold, and coliforms. So this is an opportunity to target those areas, particularly when you're cleaning and sanitizing the harvester. And the growers should be cognizant of how the lugs are handled. Sporadically we would get counts on the lugs, and it tended to, it could be fecal coliforms. So, be cognizant of how you handle your lugs, where you store them overnight. Are there birds overhead under the equipment shelter? Those types of things. So just be careful of that. And, the Enterococci and the fecal coliforms, our fecal contamination indicators, they're only sporadically detected. And when they were detected, only at very low levels. So that's good news. But, of course, there is room for improvement in cleaning and sanitization of harvesters. We do want to take our due diligence because we don't want to have foodborne illness outbreak. But it is important to note that fortunately the harvesters are not showing a direct impact on the microbial load of the fruit. So for future plans for this research, and this is in process right now, identify representative aerobic bacteria, yeast and mold isolates, cultured from harvester surfaces so that I can use them in some biofilm assays because I want to test biofilm development of these isolates, and then of course subsequently cleaning and sanitization on those isolates. One interesting thing, again, I'm more of a plant pathologist by training. We do want to kind of take a look at biofilm development of these isolates in correspondence with a plant pathogen. For example, Exobasidium maculosum has kind of a sticky yeasty stage, and we suspect that potentially that could be transmitted field to field through the harvester. And, you know, biofilms are very interesting in that they could potentially protect that plant pathogen. And, you know, again, that's going to be something we need to look at. Not only do we want for food safety application, we want to make sure these harvesters are clean and sanitized, but also we don't want to spread plant pathogens as well. And so, of course, want to test cleaning and sanitizer efficacy on these different types of harvester surfaces. And as part of the SCRI grant, there's been some different novel surfaces that they've looked at, some padding and some nettings and some different surface types like that. So those will probably be added to the assay as well. But ultimately, we want to also have a rapid method check for the growers, because again, that Primus GFS audit is very intense, and so there has to be documentation that the harvester was cleaned and sanitized. And you know, a lot of them even also say that, you know, does the grower have a method for checking that it is? And, you know, visual verification may not be enough, but if you have, you know, a quick stick or something that you can just swab your harvester right quick and show, okay, it's good, it's clean, then that, again, that's going to give you some more sturdiness to your food safety practices. Any questions? Okay, the question was, were these mechanical harvesters clean? No. So at the time, and again, the Georgia growers are doing better now, but at the time, I mean, you know, they may rinse the harvester, but otherwise, I mean, it was, you know, dirty harvesters. And that I wanted it to be that way because I wanted to test, okay, if we did absolutely nothing, what would be the result? And that's kind of the good news here is that, well, if you do nothing, you know, typically you're not going to add microbial insult to the fruit. So that's good. So imagine if you do, you know, a nominal cleaning and sanitization protocol, then that's definitely going to help tremendously.
Any more questions for Renee?
We want to make this as painless as possible for the growers. So I know it's new regulations coming down. I know the third-party audits in order to ship your fruit, you know, and have more accessibility as far as where all you can ship your fruit is under kind of intense scrutinization. And I just want to really help with this because I know the growers are under so many constraints financially already. And so we want to make it, you know, cost-effective and cheap and but also as painless as possible, quick, rapid. You know, they'll have very limited amount of time because you're working on so many other things. So trying to address this for the growers, that way the growers aren't having to worry about it too much.
Oh. I don't use this. Do you recommend any particular sanitization solvents or anything like that? Or are you just saying at this point water's adequate? Or how are you recommending that to your growers?
Okay. So that's kind of the next step with the research is kind of comparing the efficacy of the different sanitizers and kind of cleaning practices. Audits are kind of vague. I don't think they specifically say you have to use a particular sanitizer or cleanser. But I do think it would be useful for the growers to kind of have a nice packaged cleaning SOP to go by. But, you know, I have to be careful about this. We don't want to limit the growers and say, well, you have to use this product or this sanitizer. But I think we do want to just verify that, you know, say you have 5 sanitizers to choose from, that at least, you know, most of them are getting the microbial load down where we want to see it. So we just want to kind of verify that for the growers. But there's all kinds of options. And again, we have to worry about corrosiveness on the different types of materials in the harvester. But quaternary ammonium is cheap and, you know, relatively safe on the environment. There's, you know, peroxyacetic acid. I've heard growers over here use bleach. So there's a lot of different options and directions. And then never underestimate the power of friction. I mean, you can get rid of microbes on your hands just by wiping your hands very vigorously with friction. So just even the cleansing process alone should help a lot. And we will compare that just to basic cleaning too. I know food safety is not everybody's favorite topic.
Great. Well, thank you so much, Renee.
Okay. Thank you for having me.